Hello, this is Mrs. Brown, and today we're going to be doing double distribution. So this is the introductory video. There'll be a second video that'll do more practice. But distribution sounds a lot like the distributive property. Double distribution is no more challenging than distributive property. You're just distributing twice instead of once. So let's take a look at this problem. I'm actually going to break this up and look at it separately. If I just had x times and then 2x minus 3, and I had 7 and I had to distribute to 2x minus 3, what would those look like? Okay, so remember that when I distribute, I'm going to go this times this, and I'm going to distribute to each term. Terms are separated by addition and subtraction signs. And again, for here, I'm going to distribute it here and to the second term because, again, terms are separated by addition and subtraction signs. So when I look at this, x times 2x, well, the coefficient's 1, so 1 times 2 is 2. And then x times x, that's x to the first times x to the first, and 1 plus 1 is 2, so it's x squared, minus, and I only have a 3, I don't have an x here, so 3 times the coefficient would be 1, so 3 times 1 is 3, so it's just 3x. When I take a look at this one, okay, 7 is just, there's no x, so it's just the coefficient. 7 times 2 is 14, so that's 14x, minus 7 times 3 is 21. So again, that's what it would look like when I distribute if I did just x times this and 7 times this. Well, when you do double distribution, that really is what you're doing. You're just doing it in the same problem. So I would be doing x times 2x and x times 3, just like I did, and I would be doing 7 times 2x and 7 times minus 3. So I'm just double distributing. So each term here has to be multiplied by each term on the other one. So if I look at this, x times 2x is 2x squared, because x times x is x squared. X times minus 3 is minus 3x, just like I found down here. And then I'm going to do plus 7 times 2x, which is 14x, because I'm multiplying 7 times the coefficient. And then 7 times minus 3 is minus 21. So you can see that this piece matches this piece, and this piece matches this piece. It's the same thing. I'm just doing it all as one problem instead of two separate problems. Okay. The last step is to combine like terms. So remember that x squareds can't go with x's, but x can go with another x. So minus 3 plus 14, well, 14 minus 3 is 11. So I would combine these two to get 11x. I still have a minus 21, and I still have my 2x squared. So this is the final answer. So again, double distribution just means I'm using the distributive property twice. I'm distributing the first term here to both and the second term to both, and then combining like terms. Okay, so let's take a look at another example. Oops, wrong one. Let's say I had x plus 1 and 2x plus 3. Okay, so what am I going to do? I'm going to double distribute. So that means I'm going to take this x and I'm going to multiply it by the first term here and by the second term. And I'm also going to take this 1 times the first term and the second term, because remember, terms are separated by addition and subtraction signs. So from here, x times 2x. Well, this is a coefficient of 1, so 1 times 2 is 2. X to the first times x to the first is x squared. X times 3 is 3x. Now I start here. 1 times 2x is 2x. 1 times 3 is 3. Once I've distributed, notice I've got 1, 2, 3, 4, 1, 2, 3, 4. Okay, if you end up with only 3 before you combine like terms, then you know you missed something, so double check. 3x plus 2x, I'm going to now combine like terms. Those go together. And that's my final answer, okay? When I multiplied these two binomials, I ended up with this trinomial after I combined like terms, okay? Let's take a look at another example. Again, I'm going to double distribute. So I'm going to use the distributive property twice. So 2 times 3x and 2x times minus 5. And then I'm also going to be doing 7 times 3x and 7 times minus 5. So again, I'm taking the first term here, multiplying it both terms, taking the first term and multiplying it both terms in the other one. It's like having two separate distributive property problems within one problem. Okay, so 2x times 3x. Well, 2 times 3, because I treat the coefficients like I normally would, 2 times 3 is 6. X times x is x squared. 2x times minus 5 is minus 10, because 2 times 5 is 10. 7 times 3x is going to be 21x. And 7 times minus 5 is minus 35. Now I combine like terms. X squareds don't go with x's, but I can do minus 10x plus 21x, which 21 minus 10 is 11. Okay, and it's positive 11, so that's going to be a plus. And I've combined like terms. Okay. One more example, and then we'll leave that at the introduction. Okay. So, So if I take a look at this, same process. I'm going to take the first term, the 3x, and multiply it by both terms in the other parentheses. And I'm going to do the same thing with the 2 and multiply it by both things in the other parentheses. So when I take a look, 3 times 1, because the coefficient would be 1, is just 3. X times x is x squared, and I still have a y. There's no y here, so it's just y. Plus 3x times 4. So 3 times 4 is 12x. 2 times xy is 2xy. And 2 times 4 is 8. In this case, when I'm looking, this has an x squared y. Since it has an x squared, not an x, I can't combine it with this. I can't put this with this because this has an x and this has an x, but this doesn't have a y, and this has a y. So again, the variables have to match, and they don't. So this is actually the final answer in this case. I can't combine like terms. Okay? I hope this helps, and have a fabulous day.